this is section 6.3, which is equations that contain absolute values. First thing we need is something called a solution set. You can see here it's just all the answers that are solutions to an equation. The book is going to write things in solution set notation. We're not really going to need to do that, but we'll look at one example here where they do that. So the first one is find the solution set of the absolute value of x equals 15. So we know there are two numbers that do that. It's both 15 and negative 15. So in solution set notation, you'd say x is 15 and negative 15. Then you'd say, therefore, the solution set is negative 15 and 15. And that's all you need for that. Again, we're not really going to need to do that. We can just write this for all of our solutions. So let's look at some equations and how we're going to solve them. We start off here, find the solutions of the absolute value of 5x minus 7 equals 62. So we know that if 5x minus 7 equals 62, then this will be true because the absolute value of 62 is 62. But we also know that if 5x minus 7 equals negative 62, that this will also be true because the absolute value of negative 62 is 62. So we're going to solve both equations separately, and that'll give us our two answers. So we add 7 to both sides. We get 5x equals 69. X is 13.8. Over here we solve this, and we add 7 to both sides. 5x negative 55. X is negative 11. And we'd say x is negative 11 and 13.8. We usually write our answers here in numerical order from least to greatest, but it doesn't really matter. It's not wrong if it's a different way. This is just the standard way of doing it. Another example. This one is the tiniest bit different. We'll see we have x plus 17 equals negative 8. Maybe x plus 17 equals 8. When we solve this, we'll get x is negative 25 and x is negative 9. The issue we have here is that if you check these by plugging them back in to the original, you'll see that neither of them work. They both get us 8, but the absolute value of 8 is not equal to negative 8. And maybe if you're pretty astute, you noticed that here we have an absolute value set equal to a negative number. And we know that every absolute value will always yield a positive result. So if we get a negative, that means that there are no solutions to this. So you can say no solution, or you can just give the null set, which will work just fine. Here we have an example. We have something else going on. The first thing we have to do is get the absolute value by itself so we can get rid of that absolute value. So we have 40, let's subtract 42 from both sides. And we'll have negative, or the opposite of the absolute value of x plus 3 equals negative 27. Now you might be thinking back to the last example where we had a negative over here, and we said, well, that means that we can't have any solutions. But that's actually not the case because there's also a negative sign over here in front of the absolute value. So we can multiply both sides of the equation by negative 1, and those negative signs are going to go away. I'll have x plus 3 equals 27, which means that x plus 3 equals 27, or x plus 3 equals negative 27. So we get x is 24, x is negative 30, so x is negative 30 and 24. Those would be our two solutions, negative 30 and 24. Here I have 5 problems for you to practice. Why don't you try all 5 and then come back and check the answers. You can just pause the video now to try all 5. And then again, once you've tried all 5, come back and I'll show you the answers. So hopefully you took an opportunity to solve these 5 questions. Here are the answers that I got. For this first one, I have x equals negative 29 and positive 29. Over here, I have x equals 201 and negative 197. Down here, I have x equals negative 13 and 9.5. Over here, I have x equals negative 12.5 and 9.5. And then down here, I have x equals, I believe it's a negative 26 and 36. So if you got all these correct, you can end the video now, you're all finished. If you didn't get them correct, I'm just going to go through and show the work for each problem so you can see where maybe you went wrong. This first one is pretty straightforward. The only two values that work for this are negative 29 and 29. The second one here, where we would have to do x minus 2 equals 199, and x minus 2 equals negative 199. This is 197, negative 201, so x is negative 2, oh sorry, whoopsies. When we add 2, we get x is 201, and here we get x is negative 197, that's better. 197, 201. That's what x would be. Here, similar, we have to get rid of the absolute value sign. We have 4x plus 7 equals 45. 4x plus 7 equals negative 45. Subtract 7 from both sides. 4x equals 38. X is 9.5. Over here, subtract 7 from both sides. 4x equals negative 52. X is negative 13. So we have negative 13 and 9.5. Here, let's add 5 to both sides first. 2x plus 3 equals 22. 2x plus 3 equals negative 22. And we're going to solve both equations, subtract 3 from both sides. And we get 2x equals 19, x is 9.5. And here we subtract 3, we get 2x equals negative 25, x equals negative 12 and a half. So negative 12 and a half, 9 and a half, those are the values for x. And finally, this one here, we're going to have 5 minus x equals 31. 5 minus x equals negative 31. Subtract 5 from both sides. Negative x equals 26. So x is negative 26. And here we subtract 5 from both sides. Negative x equals negative 36. So x equals 36. So our answers are